we'd seen that there are two ways in which a system of resistors can be placed in a circuit. First, in series like this, and second, in parallel like this. Circuits we've seen which consist of just one battery and one load resistance are very simple to understand, but they are not very often found in practical applications. Most of the times, we find circuits in which more than two components are connected together. If you want to see the resistors in a circuit, they would look like this. These three resistors are in series, and these three are in parallel. Let's dive a bit deeper into the concept with some practical examples. Take an example of this normal circuit which has just one bulb as the resistor. Once the circuit is complete, you see that the light glows brightly. Now let's add another bulb in series and see what happens. We close the circuit and notice that the brightness of each bulb gradually decreases. And if we add another light bulb, the brightness of all three bulbs reduces even more. What does this imply logically? It tells us that as we add more bulbs or resistors, the current in the circuit decreases. And that also implies that the overall resistance in the circuit is increasing. This was the conclusion for circuits which have resistors connected in series. Overall resistance increases and the current in the circuit reduces. What will happen in parallel connections? We take a normal circuit like this with one light bulb. Now before we start connecting more bulbs in parallel, we connect a test bulb in series here. The test bulb will give us an indication of how the current is changing when more bulbs are added in parallel. So at this moment, there is some current that's flowing in this circuit. Now we add a light bulb in parallel. What did you notice about the brightness of the test bulb? It increased, that's right. After we add another bulb in parallel, we see that the test bulb glows in a brighter fashion. The overall current in a circuit increases as the number of resistors connected in parallel increases, which means that the overall resistance in the circuit decreases. This activity demonstrates the changes in current and resistance when resistors are connected in series and parallel.